Hi everybody, and welcome to week 3 of the Statistical Equation Modeling 1 course on confirmatory factor analysis. In this week, I'll talk about the mean structure. So we're going to add the mean structure to the model, and that will be useful in multi-group comparisons, where we can do a lot of powerful things. So let's first talk a bit about what can we actually do with confirmatory factor analysis and statistical equation modeling. Because in the last week you already learned a lot, and actually I went quite quick with the last 2 weeks because I want to get you somewhere where you could already understand a lot of literature. After last week, you can understand probably 80% of the literature on confirmatory factor analysis, because most literature is just that, fitting a factor model like that, looking at fit indices, maybe comparing three models, things like that. I want to already introduce it faster so we can get to this week, which I think is by far the most important, where we can show some really powerful techniques that can be very useful and very important as well in research, and that are not actually used that much yet. I think they should be used more than they're used now. So let's first talk a bit about the main applications of confirmatory factor analysis of statistical equation modeling. One main application would be to form a scale. Okay, so say we have a fitting factor model, it fits, then we can use, I had one slide on it in week 1, we can use the equations from there to get a weighted sum score, and that could be our scale. And then we could publish our scale and say, okay, if you want to have a factor score per person from this scale, you can weigh your items, your response pattern with your in this way, that's based on these factor loadings, things like that. And then you get an optimal predicted latent variable per person. That's nice. Actually, you don't see it that much. People mainly just still take sum scores, which is a bit weird. But okay. And also, if you have these factor scores, they're nice, but it turns out we don't actually need them for many hypotheses that we might want to answer. Okay, week 2. We also are now able to test and hypothesize factor structure and to look at like correlations, for example, with the latent devil. All right, so if you have an idea about a factor structure like this, where this is some factor and this is some factor, and you all have these ideas now for the final project, then it might be useful to see if, okay, if this is true, can we test that? If this factor structure is true, well, we can try to reject this. It doesn't mean that if the model fits that actually this is the true model, because it could be something else, right? Like a network model, for example, is an argument we often make. But at least we try to reject the hypothesis that it's model analyzed data, so we can test for that. We can test for the factor structure, which is nice. And then we can also look at things like this correlation, for example, or which of these items are good indicators, which are not. Maybe there's a cross-loading that might be of interest, things like that. And that's very useful knowledge. And then next week we're going to extend this a bit, and we're going to do like some more complicated things like higher order models, and we have a bifactor model and stuff. And those are all a bit more advanced hypothesized factor structures. And that's week 2. And that's actually what you'll see many people do with CFA analysis. That's where they stop. But now we're going to do some really strong and powerful techniques. What we're going to do in this week is we're going to be able to test if a test is fair or biased. It's called measurement invariance. And that allows us to test if a questionnaire or a test measures the same thing in 2 groups. And another thing that we're going to do is we're going to compare groups on means and variance coefficient structure. And I think this is a very important thing, because this is actually something that people in psychology do all the time. So many people in psychology, they have, for example, a experimental group and a control group, or you have 2 other groups that you want to compare, right? And then you have some sort of dependent variable, and then you do like a t-test or an ANOVA to see if there's a group difference in that dependent variable. That's like a very substantial amount of research that does this kind of work. Well, what if this dependent variable is not observed but latent, right? And that's actually, I think, often the case. So often people are interested in this level in psychology where we cannot really directly observe it, right? Like, for example, personality aspects or facets or mood states, things like that. Many things are actually very hard to observe directly. Maybe symptoms is an example of something that would be observed directly, but then still you might be interested in comparing underlying disorders if you believe they are there. So what do you do then? Well, often people will just take a sum score of a scale that has some sort of good reliability, things like that, and then just run a t-test anyway. That's a worse way of doing this. Because what you're doing then is first you're actually using a scale, right? So you're using a factor score, a bad factor score, because you're using a sum score. And the sum score is not even weighted with factor loadings and things like that. So you're using a bad factor score, which is also not really a great estimate of the factor itself. And then you're comparing groups on it. But we can see this week that we can actually do this whole thing without ever having to compute a factor score. Directly by testing differences in the means using the variance coefficient structure and the mean structure of the data, which is a very powerful technique. So basically what we are going to do this week is we're going to replace the t-test. And actually, if you have multiple latent variables, like here, we're going to replace the hot links t-test. Right? We're going to replace ANOVA if you have multiple groups, or the MANOVA. We're going to all replace that, and we're going to do SEM or CFA, which is pretty cool. In the SEM2, we're going to take it much further, and we're going to test causal hypothesis between observed and latent variables. And actually, we are already testing a causal hypothesis between the latent and observed variable. That's this arrow here. But then we're going to do things like an effect between latent variables, or we can even do like a directed acyclic graph between observed variables and test these implications in the data as well. All without ever having to compute a sum score or to compute a weighted sum score. That's all very powerful. So that's why I think this week is very important. It's very useful, and also because it also is important because the fairness of a test is important to know, because a lot of research is based on comparing groups on something, and it turns out that it's a completely unfair comparison, and that led to a lot of research that's questionable. And a lot of this is also very sensitive, right? So for example, people are comparing like in-group and out-group, or minority or majority, or people are comparing countries on their IQ levels, things like that. It's a very sensitive topic. All right, so let's go to an example. This is already a very old example. It's not necessarily a CFA example. You would probably earlier analyze this with IRT, but it's the same principle. So here we have a test of an IQ test or an ability test. And the question is, what is missing from these pictures? Okay, so we have pictures here. So in 1, what is missing here? Well, I guess it's a mouth, right? And in 2, there's an eye missing here. And in 3, there's a nose missing here. And in 4, well, I don't know. Maybe a hand or a spoon or glass. I guess a spoon. I'm not entirely sure. All right, so we can go on. So what's missing in 7, for example? In 7, this is this little thingy here in a light bulb. In 8, this is a stand. All right. In 9, these are the strings on the violin. In 11, this is a very American question because it's a gun, and I am not as familiar with guns as other people are. I think it's the trigger. I'm not entirely sure. In 15, maybe the racket. All right. Etc. etc. So this is a questionnaire designed to measure native intellectual ability. And this is already very old. This is a very nice article on this. The original author is from 1914 or so. It's like very old. Argued that this measured native intellectual ability Or in other words, innate intelligence which was unaffected by cultural and educational opportunities. So unaffected by cultural and educational opportunities. Well, that doesn't seem quite right to me, because, okay, it's like the mouth and the eye and the nose, I can imagine. But the stamp, for example, on a postcard, that seems something definitely very cultural, especially in that time. That might not have been a very normal thing in many cultures. This light bulb in 1914, that might not have been something that was there in many cultures. And then especially things like a violin and how to play tennis. Well, those are very big differences in cultures if you actually know that, right? So if you don't grow up in a culture where people play tennis, you don't know that there's a record missing here. You just see people standing there. So there's quite a lot of items in here that definitely are not affected, or they are affected. Now, what did the author do here? He used this test to compare, I think, men for the army, if they were suitable or not. Then he came up with some arbitrary cutoff to define if people are morons or not. And then he defined that the average man in America was a moron, and that was the point. That's okay, that's already a bad statement to make, but then he went further on to then compare American men to men from other cultures, and to compare American white men to American black men. And then it turns out that black people in America had a lower level of this than white people, so you can imagine what the conclusion would be there. And that does not take into account at all that there are very strong differences in not only culture, but also like in poverty. I think especially in 1914, also in America, right, where you can imagine a ton of ways in which this test does not measure native intellectual ability, but it measures something completely different. Right? So that's a completely unfair comparison to make then. And and that's why I think these kinds of tests for measurement invariance are hugely important, because you need to prevent people from making these kinds of statements, even though you can easily show that they're biased, and you can actually show that statistically as well. And so you can read up a bit more about it here on this link. It's an interesting link to read. Now this is 1914 or so this is a century ago. So you might think that this is not really the case now anymore, but actually surprisingly, this kind of stuff still happens a lot now. There's a lot of literature, for example, on national IQ, where also American test for intelligence was used across the world to measure IQ. And that had items like pictures of people going into a laundrette, and then you have to put them in the right order. And that's something that I don't even know how to do, because I don't go to laundrette. That's completely affected by cultural differences as well, of course. And then the conclusions of that are very striking. They're not only showing or saying that people, I think the theory is that the closer people live to Africa, the less intelligent they are. And then they're also trying to explain that biologically, or not biologically, evolutionary. Even though this result is just completely also based on violations of measurement invariance. And this is relatively new still, and I think you still see this kind of research popping up, of course, and this will always be an important topic, I think. Right? So when you're going to compare groups, you need to be absolutely sure that your comparison is fair. And that's something that we can do in using measurement invariance testing. And quite often you will see that this is not the case. So this is also an example where from a Dutch study, and this is a nice paper by Jelte Wiggers and Connor Dolan. Connor Dolan used to teach SEM actually in before me and before Mike and Abdullah here. And they had a commentary on this this study, where they also investigated like IQ differences between Dutch minority and majority groups. And again, measurement invariance was violated, so you cannot really make these statements. Okay, so that's it for the introduction for this week. I wanted to take a bit more time introducing this topic because I think it's an important topic. So many researchers investigate group differences, and they do that, for example, by just taking a sum score without taking measurement invariance into account or measured into account. And this can sometimes be followed by very strong theories, like evolutionary theories on why groups differ. But it turns out that we have actually a methodology to test if a test is fair or not. And that can be used to answer many important questions. And I think it should be used more, actually. For example, should students with dyslexia get more times on exams? We can actually just test if an exam is fair or not for a group with dyslexia and a group without dyslexia. And what we'll also see is that if measurement invariance is violated and you want to form a scale, then you should bias the scale in one group versus the other group. So you should make it a bit easier for one group than for the other group. Many people will object to that as well. So maybe instead you just want to remove the items that are biased, things like that. And once we have that out of the way, the measurement invariance testing, we can compare groups. And we can compare them without ever having to compute a sum score. We can just compare them using SEM and CFA. But before we do that, we have to extend CFA with the mean structure and multi-group analysis. So that's what the next 3 videos will be about.